Hi Bobcats, this is Miss Lee, and today's video lesson is on solving two-step equations. Please make sure that you're taking good notes as you watch the video. Okay, to solve two-step equations, you perform the order of operations backwards. So we've already learned how to solve one-step equations. And by one-step equation, we mean where there's only one operation. And we learned that you have to isolate the variable, and to do this, you do the inverse operation. So if you have x plus 3 equals 10, then you would do the inverse operation of adding 3, which is subtracting 3. But now we're going to be working with equations that have more than one operation, that have two operations. And we call these two-step equations. And to solve them, you have to do the order of operations backwards. Okay, so the operations are going to be a multiplication or a division, or it's going to be an addition or subtraction. And you do them backwards. Normally, PEMDAS tells you to do the addition subtraction step last. Well, that's going to be the first step that you do. Okay, so step 1, undo the addition or subtraction to remove the constant term. Remember, the constant is just a number. It's just a number that's being added or just a number that's being subtracted in your equation. We're going to undo that step first. And then step 2, you undo the multiplication or division by removing the coefficient. Remember, the coefficient is what goes with the variable. It's being multiplied with the variable. And division, it could be division 2. Multiply or divide with the variable. That's the coefficient. Then step 3, you check your answer. So we're just going to get right into it and start some examples. We have a model here. We're going to use this model to solve. 3x minus 4 equals a negative 10. The first thing you want to do is what? Remove the constant, that just a number. So looking at our model, there are 4 negative unit tiles. The opposite would be to make a zero pair, to put 4 positive unit tiles. So let's go ahead and do that. Make sure you put your positive symbol. And remember, what you do to one side of our model scale, you have to do to the other side. So I'm going to add 4 positive unit tiles here. And now looking on the side of our variable, our unit tiles, 4 negatives, 4 positives, they zero out. So I'm going to cross them off. Then I look at the right side. I do have negatives and positives, so I need to cross off my zero pairs. Since I have a lot of negatives and 4 positives, then I can cross off 4 negatives and 4 positives. So now that leaves me with 6 negatives on the right side and 3 x's on the left side. And one thing I did forget to do was I forgot to draw my equals line. That helps me separate the two sides. Okay, so now I know that 3x is equal to negative 6, right? But I want to know how much 1x equals. So I want just 1x. So I need to split these 6 negatives equally among our 3 x's. So if I do that, that means each x gets 2 negatives. So this group of 2 negatives would go to this x. This group of 2 negatives would go to the middle x. The last 2 negatives would go to the last x. So 1x would equal 2 negatives. So that is our answer. X equals a negative 2. And then you can go back and check your answer. Plug in negative 2 for x. So let me change my color. I'm going to do it up here. 3 times x, which we're going to substitute with a negative 2, minus 4 should equal negative 10. Now we do the regular order of operations. We do multiplication before subtraction. 3 times a negative 2 is a negative 6. Now we're going to go ahead, combine the negative 6 and the negative 10. The signs are the same. Add them up and keep the same sign. Does a negative 10 equal negative 10? Yes, it does. We solved it correctly. So x equals a negative 2 was our answer. Pause the video if you need to go back and process everything we did, or if you want to listen to it again, just rewind it. When you're ready to go on, move on to the next problem. Okay, so now we're going to solve equations without using the models. So we're going to follow the same steps we did for one-step equations. Draw your equal line. This time, we have to do PEMDAS backwards. So we're going to undo any addition or subtraction. We want to remove the constant. So the side, where's the variable at? The variable is over here on the left side. So where's the constant? Right here. Positive 50. So we want to do the opposite. The opposite of positive 50 is a negative 50. What you do to one side, you do to the other side. Now, do the math. We haven't done anything with the x's. We're not combining any x's yet. So we bring down the 2x. The positive 50 and the negative 50 zero out. There's no need to write plus 0. Okay? Then 120 minus 50, different signs, subtract. It's going to be 70. There's more positives, so it's a positive 70. But we're not done yet because our x is still not isolated. Okay? What do we have going on the same side as the x? Well, now we're multiplying the x by 2. So we have to do the inverse of multiplication, which is division. I'm going to show my division by using the fraction bar. I'm going to divide by 2. What you do to one side, you do to the other side. So 2 divided by 2 gives us 1x, or just x, equals, and 70 divided by 2 is 35. So my final answer is x equals 35. Check our answer. Come back in, plug in 35 for x. 2 times 35 plus 50 should equal 120 if we solved it correctly. Well, order of operations says to multiply first. 2 times 35 is 70. Add the 70 to the 50, and do we get 120? Yes, we do. So we solved it correctly. We can put the solution on a number line. X equals 35. So here's my 35, and this is what x equals. So I'm going to put a filled in circle dot at the 35. So I want you to go ahead and pause the video and solve the next two problems on your own. Remember, you need to do the inverse operation of the constant first. We have to remove the constant first. Then we can remove the coefficient. Okay, let's see how you did on the second one. Get rid of the constant first. The constant is a negative 10. The inverse of a negative 10 would be a positive 10. So you can add positive 10 to both sides. Bring down the negative 4x, the 10 zero out, 50 plus 10 is 60. We're not done because the x is still not isolated. Now it's being multiplied with a negative 4. So you do the inverse of multiplying, which is division. So we divide both sides by negative 4, and we get x is equal to negative 15. Go back, check your answer. Plug in negative 15 for x. Negative 4 times the negative 15 minus 10 should equal a 50. Well, negative 4 times negative 15, negative times a negative is a positive 60. Minus 10 does give you 50, so it was solved correctly. How'd you do? Okay, next one. Okay, this one's a little bit different because you have the constant first, and the constant is a positive. So the opposite of this positive constant would be a negative 2.5. So we're going to put negative 2.5 on both sides. That zeroes out, leaves you with a negative 2p on the left side of our equal sign, and 11 minus 2.5 gives you a positive 8.5. Okay, now look at your p, look at your variable. It's being multiplied by a negative 2, and the opposite of multiplying by a negative 2 is to divide by a negative 2. Divide both sides by a negative 2, and p equals a negative 4.25. Come back, check your answer by substituting negative 4.25 for p. So you have 2.5 minus 2 times a negative 4.25 equals 11. Do the math. 2 times a negative 4.25 gives you a negative 8.5. Then you have 2.5 minus a negative 8.5. Remember, the double negative turns into a big old positive sign. Two positives, add them up. 11 equals 11. That is true. So p equals negative 4.25 is the correct answer. Again, if you got it wrong, pause the video. You can listen to it again, check the steps, see where you made your mistake. Once you're ready, move on to the next problem. Okay, we actually have three more examples. So trying to think. Let's go ahead and do this middle one together. S divided by 3 minus 4 equals 2. So of course the first step is draw your equals line. Identify which side your variable is on. S is our variable. It's on the left side. Now we need to get rid of what first? The constant. This negative 4 is the constant. So the inverse of a negative 4 is a positive 4. What you do to one side, you do to the other side. Do your math. We haven't done anything with the s divided by 3. Here, the negative 4, positive 4, they zero out. And 2 plus 4 is 6. Okay? S is still not isolated. S is now being divided by 3, so we need to do the opposite. And the opposite of dividing by 3 is what? Multiplying by 3. That's the inverse operation. What you do to one side, you do to the other side. So let's do the math. Here, our 3's simplify to 1, or just S, equals, and 6 times 3 is 18. So our answer is S equals 18. Check your work. And come back in here and say, okay, let me replace S with 18. So 18 divided by 3 minus 4 should equal 2. Order of operations says to divide first. 18 divided by 3 is going to give us a 6, and 6 minus 4, does that equal 2? Yes, it does. We solved it correctly. And then you can represent the solution on the number line. The solution is 18, so I'm just going to put 18 right here and put a filled in circle dot. There's your solution. Okay, pause the video, solve the remaining 2 problems, come back and check your work. Okay, the first one, did you get y equals 12? If you did, great job. The last one, did you get that z equals 12 or 12 equals z? If you did, good job. If you got either one of those wrong, go ahead and pause the video, see where you made your mistake at, and then move on to the next problems. Okay, our last 2 problems is that we need to select all of the equations that have a solution of x equals 14. So we're given a solution, we're saying, hey, x equals 14. Well, which one of these equations will make it true where x does equal 14? So all you have to do is substitute 14 for x. So I'm going to rewrite this over here. This is going to be 2 times 17 minus 14 equals 6. So I do the math. Parentheses first. 17 minus 14 is 3. And does 2 times 3 equal 6? Yes, it does. So A is the solution. Okay, let's try B. You're doing the same thing. 3 times 12 minus x. What is x? A 14. Should equal a 6. So order of operations says do PEMDAS first. 12 minus 14. The signs are different. When the signs are different, what do? Subtract, right? You get a 2. There's more negatives, so it's a negative 2. So now we have 3 times a negative 2. Does that equal a positive 6? No, it equals a negative 6. So B, 14 is not a solution for B. Okay, so we keep doing the same thing. 2 times x, substitute 14 for x, minus 3 should equal 22. Multiply first, 2 times 14 is 28, and 28 minus 3 equals 25, not 22. So C is not a solution. And the last one, 2 times, substitute 14 for x, minus 3 equals 22. Parentheses first, 14 minus 3 is 11. Does 2 times 11 equal 22? Yes, it does. So A and D, x equals 14, is the solution for the equations for A and D. Okay, great job, Bobcats.